rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S Chand Academy, the official YouTube channel of S Chand Publishing. And the book here is Mathematics for IIT-JEE Main Advanced by Khanna sir, and I am Subuh Nadeem. So let us see what are the chapters in this book that we have already seen. So the chapter which we have to do today is the hyperbola. This is actually the next chapter after ellipse, and this is the 22nd chapter of the book of volume 2. And first, some important concepts of hyperbola. So basically, if we take equation of a hyperbola in its standard form, that is x square by a square minus y square by b square is equal to 1. Now what do we have here? Here there is a focus a comma 0, and there is a directrix here x is equal to a by e. But unlike ellipse, here eccentricity is actually greater than 1. That is why focus is on the right and the directrix is on the left of the hyperbola. Here also, in this branch of the hyperbola, directrix is here and the focus is here. Now if we take any point, its distance from focus by this, so PS by PM, that is the eccentricity, is actually greater than 1, and we have from here PS greater than PM, as eccentricity is greater than 1. So similarly, if we take this focus and this directrix, we will have the similar result, as we have two foci in case of ellipse also and two directrices in case of ellipse also. Similarly in hyperbola is the condition. Now what is the relation between b, a and e? B square is equal to a square, e square minus 1, like this. And we have a comma 0 as its vertex here, and 0 comma b and 0 comma minus b are the points on the transverse axis, and the hyperbola is not intersecting the transverse axis. And this is also minus a comma 0. This another vertex. So these are the few terms which we have to know. Other than that, we have to know about the latus rectum. Latus rectum is the focal chord which is perpendicular to the transverse axis of the hyperbola. This is the conjugate axis. Y axis is the conjugate axis. X axis is the transverse axis here. So if this is the latus rectum, its length is equal to 2b square by a. As in the case of ellipse also, same result is there. And if we see its end point, then it will be a comma b square by a, and here it will be a comma minus b square by a. Now we have to see some few results on hyperbola, like we have tangent t is equal to 0. Now what do you mean by this? X1 by a square minus y1 by b square is equal to 1. Now if x1 y1 point on the hyperbola is taken in parametric form, it can be taken as a sec theta comma b tan theta. So if we take the hyperbola and we talk about its auxiliary circle, so what will be the auxiliary circle? It will be a circle like this, which will be x square plus y square is equal to a square, and the hyperbola is x square by a square minus y square by b square is equal to 1. Now if we take a point a sec theta comma b tan theta somewhere here, this point is P, let us say this point is P, a sec theta comma b tan theta, right students? So what will happen? We drop a perpendicular here on the transverse axis of the hyperbola, and then from here we take a tangent to the circle, and the point where this tangent will touch the circle is a cos theta comma a sin theta. This is the point here. So this is the importance of auxiliary circle, and this line, when you will join with center, this angle will be theta, which is the eccentric angle. So theta, which is the eccentric angle here, is actually representing geometrically this point on the auxiliary circle of the hyperbola. Okay students, now After knowing this, we can also find from a point the chord of contact, and we know that chord of contact, if suppose we take a point here like this and we take a tangent like this, pair of tangent, and then we join this is the chord of contact here. So this chord of contact will have equation again t equal to 0. A chord with midpoint x1 y1 y will be equation t is equal to s1, as we see in cases of circle, ellipse and parabola also. Now if we talk about next point, so next point is a slope is given of a hyperbola, of a tangent of a hyperbola, and you have to find the intercept. So what will happen if we have a hyperbola like this and there is a tangent, its slope is m, so its equation will be y is equal to mx plus minus root over a square m square minus b square. So only change from the ellipse is that there it was plus b square, here it is minus b square. So you can also say, since in ellipse it is x square by y square, sorry, x square by a square plus y square by b square is equal to 1, and in case of hyperbola it is x square by a square plus y square by minus b square. So you minus sign you have taken here, minus from here of hyperbola you have taken here. So b square is replaced by minus b square in case of hyperbola, whereas in ellipse it was plus b square. So in the equation of tangent also plus b square is replaced by minus b square. This is how you can remember the result. Now there can be two tangents, one tangent this, one tangent this. This is a positive intercept, this is a negative intercept. Okay students, fine. Now if you want to find something about a rectangular hyperbola. So what is a rectangular hyperbola? So rectangular hyperbola is a hyperbola whose asymptotes are perpendicular to each other. Now point is that what are the asymptotes? So first let us talk about asymptotes. Asymptotes are tangent at infinity to the hyperbola, but they are at a finite distance. So if we take, suppose, a line like this and a line like this. So this is pair of line which are the pair of asymptotes. Two lines are there which are called pair of asymptotes, and this is a tangent to this hyperbola at infinity or minus infinity. So basically if we talk about the equation, so this line will be y is equal to b by ax, and this line will be y is equal to minus b by ax. So the combined equation will be x square by a square minus y square by b square is equal to 0. In case of hyperbola it is 1, in case of the asymptotes it is 0. So the pair of lines will come out to be, one is y is equal to b by ax, another is y is equal to minus b by ax. Now in rectangular hyperbola they are perpendicular to each other. So if we talk about rectangular hyperbola and we say that there are two asymptotes which are perpendicular to each other, so they are 90 degree to each other. So you can say that b by a is equal to tan 45 degree. So in that case b is equal to a. So rectangular hyperbola is of the form x square minus y square is equal to a square, because b and a both are equal. And if you talk about the eccentricity, so b square is equal to a square into e square minus 1. Now you take a square and b square equal, so a square will be a square into e square minus 1, and a square will cancel, e square will be equal to 2, so e will be equal to square root of 2. So this will be the eccentricity of this hyperbola, which is called a rectangular hyperbola. Now if we talk about some questions, the distance between the foci of a hyperbola is 16 and its eccentricity is root 2. So first of all, if its eccentricity is root 2, it is a rectangular hyperbola, right? As we have just studied. So if this is a rectangular hyperbola, its eccentricity is root 2 and a is equal to b. The distance between the foci of a hyperbola is 16. So 2ae is equal to 16, right? And e is equal to root 2. So this will be like this. So from here, can you get a value? A value will be 16 by 2, that is 8 by root 2, that is 4 root 2. Right students, a will be equal to 4 root 2, that is the semi-transverse axis will be 4 root 2. Prove that its equation is x square minus y square is equal to 32. So x square minus y square is equal to a square is the rectangular hyperbola. So x square minus y square is equal to 4 root 2 square. That will be of course 32. So this is a direct application of the theory which we have just studied. Now let us see next question. Define conjugate hyperbola if E and E dash be the eccentricities of a hyperbola and its conjugate. Then prove that 1 by E square plus 1 by E dash square is equal to 1. So we have a conjugate hyperbola which is like this, and its equation is x square by a square minus y square by b square is equal to minus 1, like this, not 1 but minus 1. Now if we take minus on the left hand side, y square by b square minus x square by a square is equal to 1. Now if we talk about its focus, so its focus will be on the y axis and it will be 0 comma BE, right students? Now for this the eccentricity is E dash, so we are taking BE dash, the eccentricity of the conjugate hyperbola. So B square A square is equal to B square into E dash square minus 1. This is how we will write it, because now B is taking the place of A. So the relation will be now like this. And for the hyperbola we already know B square is equal to A square E square minus 1 for the standard hyperbola, which is like this, and its focus is AE comma 0. Now if we take E dash square from here, so this will give you E dash square is equal to A square plus B square by B square, and E square from here, so what you will get, A square plus B square by A square. Now let us take the reciprocal of both of them and add them. So 1 by E square plus 1 by E dash square. So B square will be in the numerator, here A square will be in the numerator, and then we will have A square plus B square by A square plus B square, which will be equal to 1. This is what we have to prove actually here. So this is what we have to understand about conjugate hyperbola. This is a vertical hyperbola like this. Now let us see the next question. If the foci of the ellipse this one and the hyperbola this one coincide, then the value of B square is. So here the foci of the ellipse first. So that will be here B square is equal to 16 1 minus E square, right, like this. Now from here you can find B square is equal to 16 minus 16 E square. So from here B square, sorry, 16 E square is equal to 16 minus B square. So you will say that 4E is equal to root over 16 minus B square, and this is actually the x coordinate of the focus of the ellipse. This is AE, as 4 is, this is A square, so A is equal to 4. So this is AE. So AE is root over 16 minus B square. So this is the focus of the ellipse AE comma 0, which is actually root over 16 minus B square comma 0. Now we talk about hyperbola. So hyperbola, we have B square of hyperbola is equal to A square of hyperbola, eccentricity of hyperbola minus 1. Now here again if we see AE, so A1 E1 is equal to B1 square plus A1 square. So this will be B1 square. B1 square, as you can see from here, is actually 81 by 25, right? It is 81 by 25. And if we talk about A1 square, this will be 144 by 25. So this is 144 by 25. When we will add them up, we will get 225 by 25, that is 9. So we will say that A1 E1, this is A1 E1 is equal to 3. So 3 comma 0 is the focus of the hyperbola, one focus of the hyperbola, which is the right side. Now we have to find the value of B square. So we will just equate them. So 16 minus B square will be equal to 9, which will give you B square is equal to 7. So this will be your answer. B square is 7, right students? Next question. The tangent at a point P on the hyperbola meets one of its directrices in F. Show that PF subtends a right angle at the corresponding focus. So what it says, student, the tangent at a point P on the hyperbola. So on the hyperbola, there is a tangent at P meets one of its directrices at F. So this is meeting its directrix x is equal to a by e at F. So this point is F. Show that PF subtends a right angle at the corresponding focus. So here this is the focus and it is saying that it is subtending right angle. In the figure it may not look like this, but this is what is happening. So this is what we have to prove. So what we will do, we will first write the equation of the tangent. So that will be x, and we have by a sec theta minus y by b tan theta is equal to 1. Now if we take PF and it is x is equal to a by e, so x is equal to a by e we take, then in that case this will give you y by b tan theta is equal to a cancel sec theta by e minus 1. So y is equal to b, and then we have this will become sin theta and cos theta will get cancelled, 1 by 1 minus cos theta into e by e. This will what will we get, right students? This calculation you can understand. This is 1 by cos theta, this is sin theta by cos theta, then we have taken the LCM and we have written it like this. So this is the y coordinate here. Now this point is a comma 0. So if we talk about the slopes, slope of PS, that will be of course this is a sec theta comma b tan theta, right? This is a sec theta comma b tan theta. So if we talk about the slope, this will be b tan theta by a common sec theta minus e, which we can write as b sin theta, and here a, this is e actually, sec theta minus e, this will become 1 minus e cos theta, right students? This is slope of PS. Now slope of FS, the point F and the focus. So this is y minus 0. So b 1 minus e cos theta upon e sin theta, and then x coordinate difference a by e minus a. So we have a by e minus a. Now if you multiply MPS with MFS, just see here, I am not doing the calculation part, but you will be able to understand what will happen. That 1 minus e cos theta will get cancelled and sin theta will get cancelled. When you will multiply them, this will get cancelled, this will get cancelled, and b square by a square will become, it will become b square by a square, and then you will multiply with e here. So 1 minus e square, this will become 1 minus e square. Now we know that b square is a square into e square minus 1 in case of hyperbola. So this is minus b square. So this is minus 1. That means these are perpendicular to each other. That is 90 degrees the angle. Let us come to the next question. If m1, m2 are the slopes of the tangents to the hyperbola which pass through the point 6, 2, find the values of m1 plus m2 and m1, m2. So it is saying कि m1 and m2 are the slopes of the tangents to the hyperbola which pass to the point 6, 2. So we can of course say that we have 6, 2 a point somewhere here like this, and there is a tangent and there is another tangent, and their slope is m1 and m2. Now the equation of the tangent is y is equal to m1x plus root over a square m square minus b square, like this. This is how we write this in slope form. m1 is there, then we write it like this. Now this is passing through 6 comma 2. So we will satisfy it by 6 comma 2. Like this. Then we will take it on the left hand side and square it. So that it will become 4 plus 36 m1 square minus 24 m1 is equal to 25 m1 square and 16. In the next step, 36 minus 25 will be 11 m1 square minus 24 m1 plus 16 m1 is minus 8 m1 plus 4 is equal to 0. Now from here m1 plus m2 you can find. What is m1 plus m2? Minus b by a of the quadratic equation. So this will be 8 by 11. And what will be m1 m2? C by a. So that will be 4 by 11. So this is how you can calculate these values. Now let us come to the next equation. Next question. A normal to the hyperbola meets the axis in Q and R. Right? So we have to draw a figure here. The hyperbola is this one. And there is a normal here. Like this. It is meeting it at Q and R. And lines QL and RL are drawn at right angles to the axis. So QL and RL like this. And meet at L. In other words, the rectangle QORL is completed, right? And further it is incomplete question. In this here, find locus of L. So if we take this point as alpha comma 0 and this point as 0 comma beta, so this point is alpha comma beta. This locus we have to find. So what is the equation of the normal? Equation of the normal is x by x1 a square, this is x1, plus y by y1 b square is equal to a square plus b square. In case of hyperbola, in case of ellipse, there will be minus here and minus here, right? Now, if we say that it is intersecting x-axis at alpha, so what will happen? Alpha by x1 a square is equal to a square plus b square. From here we will get alpha is equal to a square plus b square by a square into x1. Similarly, if we put x is equal to 0 and y as beta here, because it is intersecting y axis also, so we will get beta square. So what we will get beta? Beta will be equal to a square plus b square by b square into y1, like this. Now we know that x1 y1 is on the hyperbola. So x1 square by a square minus y1 square by b square is equal to 1. So what will be x1 square from here? A square and alpha. So you can take x1 by a also. And just take the value of x1 from here and y1 from here and substitute here. And that will be a relation between alpha and beta, and that will give you the locus, of course. So this is how we will solve this question. Next question says the asymptote of the hyperbola makes an angle of 60 degree with x-axis. Write down the equation of conjugate to the diameter y is equal to 2x. So if we have asymptote of the hyperbola making an angle of 60 degree with x-axis, that means tan 60 degree is equal to b by a, which means b is equal to root 3a, right? Write down the equation of conjugate to the diameter y is equal to 2x. So conjugate diameter. Conjugate diameter means another diameter. So there is basically the concept of conjugate diameter, that if there is a diameter like this which is passing through the center of the hyperbola, and there is another diameter which is like this, which is also passing through the center of the hyperbola. So there could be many diameters. There could be this diameter also. So if we have two diameters which are conjugate of each other, then the midpoint of the chords parallel to one diameter is actually lying on the second diameter. So if we use this relation and use y is equal to 2x here, So we will have m is equal to 2. And if m is equal to 2, we know that conjugate diameter is m1 m2 is equal to minus b square by a square. So what will happen? m1 will be 2 and m2 we don't have. This will be minus b square by a square. So b square by a square is, as b is equal to root 3a, so this is 3. So m2 is equal to minus 3 by 2. So we will say that the equation of the conjugate diameter is y is equal to minus 3 by 2x. Let us come to the next question. It says prove that from any point alpha beta 4 normals can be drawn to the rectangular hyperbola xy is equal to c square, and that if the coordinates of the 4 feet of the normals p, q, r, s be this, then you have to find the relation. So first of all, you can take any point here as parameter like ct comma c by t, and this is a rectangular hyperbola whose axis, transverse axis is y is equal to x and conjugate axis is y is equal to minus x, and this would be like this and this would be like this. Now here any point is ct comma c by t, which will satisfy it. T is the parameter, of course, and then we have normal equation. So for normal equation, what we will do, x dy by dx plus y is equal to 0. So the slope will be equal to dy by dx is equal to minus y by x, which will be actually minus c by t by ct. So that will be minus 1 by t square. That is of the tangent. Now about normal, the slope will be t square. Now when we write the equation of the normal, y is equal to minus c by t, y minus c by t is equal to slope t square into x minus ct. This is how we can write it. So the next equation after taking LCM is ty minus c is equal to t cube x minus ct, like this. So I hope you are following this, students. So this is how we will do this. Then it will become a 4-degree equation in t, that is ct to the power 4 minus t cube x plus ty minus c is equal to 0. This is a 4-degree equation, which means there are 4 roots. So there are 4 values of t, t1, t2, t3, t4. That is why this is xi, yi, and there are 4 values of I, 1, 2, 3, 4. One is ct1 by ct1 comma c by t1, another will be ct2 comma c by t2, and so on. Now if we talk about their sum of the x coordinate, that is ct. So what will happen? ct1 plus t2 plus t3 plus t4. So that will be equal to, this is alpha. Now that will be equal to minus b by a. So minus b by a if you will do, so that will become x by c, like this. So as you can see that here alpha is equal to, okay, so alpha was basically a point on the normal, so it is satisfying this. So this will be alpha finally and this will be beta finally, right? And if you see the calculation part, then minus b by a will be t alpha by c. So this will be alpha by c. So x1 plus x2 plus x3 plus x4 is not, there is a small mistake here, as we have t. So we say that t1 plus t2 plus t3 plus t4 is equal to minus b by a, which is alpha by c. So from here we will say alpha is equal to c t1 plus t2 plus t3 plus t4. Now ct1 is x1, ct2 is x2, ct3 is x3, ct4 is x4. So this is how we will write this. Similarly, you can prove for beta and you can prove the last result also. So prove that the locus of midpoints of the focal radius vectors drawn from the right hand focus to all points of the hyperbola x square by 9 minus y square by 16 equal to 1 is another hyperbola whose center is 2.5, 0. So here the question says locus of midpoint of the focal radius vector. So we have a hyperbola like this, and there is a focal radius vector like this. This is JE comma 0, and we have locus of the midpoint. This is the midpoint. And this is the hyperbola. So this will be A is 3e comma 0. And if you take the value of E, that also you can find B square is equal to A square E square minus 1. So from here E square will be 16 by 9 plus 1, which will be 25 by 9. So E will be equal to 5 by 3. So you can take this as 5 comma 0, the focus. Now we take the midpoint as alpha comma beta, and then we have any point on this hyperbola as x1 comma y1. So we take alpha is equal to x1 plus 5 by 2 midpoint, and y1 as beta as y1 by 2 midpoint. Right, students? This is how we can write it. Now x1 square by 9. So we can write it 2 alpha minus 5 whole square by 9 plus minus y1 is y square by 16. That will be y1 square by 16. So minus 2 beta whole square by 16 is equal to 1. Now further, when we calculate it, we have to find its center. So we take out 4 here. This will be alpha minus 2.5 whole square here, and 4 will come in the denominator, 9 by 4 minus beta square by, and this will become 4 is equal to 1. So this is now a hyperbola whose center is 2.5 comma 0. So this is all for today's lecture, student. I hope you have enjoyed the lecture. Thank you.